Leetcode 543, diameter of a binary tree. So you are given the root of a binary tree, and you have to return an integer, which would be the longest path between any nodes in the tree. So it doesn't necessarily mean it's from the root. It could be from any node in the tree. So for this example 1, the path does go through the root, and it is 1, 2, 3, the length of 3. The other length is 5, 2, 1, 3. That's also 1, 2, 3. And then if you're given a root of 1 and then 2, you're going to return 1 because that is the longest length. So anytime you're given a problem where you have to traverse through a tree and you have to keep track outside the root, you're going to need another method to process the tree. If you're keeping track of per node, not just root. So because of that, we are going to write another method. We're going to be using depth first search, so we can just make a recursive call and traverse through the tree in that manner. Tree node root, and I'm going to create a global answer. We can just start off as 0 that we're going to be returning into the method that is called for the solution. So at the end we are going to be returning the answer, and we're going to process the tree. I think it's probably better to call it process. We're just going to process that root. And we're going to be updating the answer as we process each node in that tree. So this is going to be a recursive method, and so what we have to do is provide the base case so it doesn't keep getting recursively called. So that would be, if our root is null, we are going to return 0. So this method is essentially looking at the nodes that are after the root. So we're saying, which way should we go? Should we go to the right or to the left? So the left is going to be processing the root left, and we know that there's a left here because this class is divided here. So we know in our tree node class we have access to a tree node that's called left and right. When a tree node is created, it's passed a value and also a left or a right tree node, which can be null. It is nullable, so this is why we can check it like this. Okay, and we're going to say our right one is going to be when we process the root right. So this is going to be going to the left, then going to the right. And at the end, this is our method again so that we can process the tree after the root. So we're going to say, we're going to have 1 plus. So basically we're looking at this not as the answer, we're looking at this as a node per this tree. So we're looking at it 1 by 1. So we're looking at this and we're going to say it's going to be 1 more down this path. And should we go down the left or the right? So we're only going to be able to traverse down one way as we're processing this because we're looking at one path. So we're going to say return 1 plus left and right. But what we can sneak in here is an update to the answer. And the answer is going to be what it is currently, or it's going to be what it's going to be the left path plus the right path. So this is the left path and this is the right path. So this is going to say, let's go this way or this way. And we're going to add 1 to it because this is the node that we're reaching now. So this is really all you have to do for this question. And again, the reason why you need another method is because we're updating the answer as we traverse through. What we're returning here is just whether or not we're going to go down the left path or the right path from a specific node. And we can run it. Oops. And do 2. And I'm going to put that there. Okay, thank you. Yes, also, if this has been helpful, please subscribe.